So now we're going to look at what happens to the period if we do horizontal stretches and compressions. So for our first one, we have cos of 6x. Can you see that that 6 is inside the function where the x is? So we're going to multiply our x values by 1 over 6. Now when we were graphing sine and cos, so for A, if I'm about to graph this, normally I put one period here, right? Which was 2 pi. If I was graphing a normal cos graph, I would put 2 pi here and then split it into 4. But now I need to multiply everything by 1/6. So I'm still going to put the line here, but what happens when you multiply 2 pi by 1/6? You get, well, I could write it as 2 pi over 6, or I could write it as pi over 3. Both of them are fine, because in grade 12, we're not worried about you simplifying fractions. And then I would have to break this into 4 equal sections. What's half of 2 pi over 6? 1 pi over 6. What's half of 1 pi over 6? Pi over 12. So what we do is when we divide things in half, we find out what one of these sections is. It's pi over 12. Once you find out what one of these sections is, you can find the third one, because it's going to be 1 pi over 12, 2 pi over 12, 3 pi over 12, which you could reduce to pi over 4 as well. So those last two fractions could be reduced, but you could leave them like that as well. What is an amplitude of a normal cos graph? 1. Do we have any vertical stretches in this one that's going to affect it? No. One of the things that you're going to find as a shortcut is whatever number's in front, none of these have numbers in front, but whatever number is in front is your amplitude. Always. Unless it's like a -4, you have to remember the amplitude is always positive. But whatever number's in front will be your amplitude. Now, where does cos start? Cos starts at a maximum. So once we got our maximum, it goes down to the center line, down to minimum, back to the center line, back to the maximum. And so you might start to notice that we're already developing some shortcuts for graphing sinusoidal graphs. Instead of taking all 5 points that were on our original graph, multiplying the x-coordinates of all 5 of them by 1/6, we just figured out what our new period was, still broke it into 4, and went maximum, center line, minimum, center line, maximum. And that was a lot quicker than doing 5 points and writing out where each of those points would end up. So for part A, our period is 2 pi over 6, or pi over 3. Part B. Not a nice number. We're graphing tan. In order to graph, we can just multiply it by 2/3, but I want you to practice your graphing as we go through. So that's why we're doing this as we go through. So notice that there's a 2/3 inside the tan. So what are we going to do to our function? Our x values are going to be multiplied by the reciprocal 3/2. So what's going to happen to our first asymptote? Our first asymptote was at pi over 2. It's now going to be at 3 pi over 4. Whoa. and this one will be at negative 3 pi over 4. If you wanted to draw one more, you could. The one that was at 3 pi over 2, when you multiply that by 3 over 2, you will get 9 pi over 4. And when you go to graph this, it still has the same shape. This is what our graph is going to look like. Now, what's our new period? Our period was pi, but because we're multiplying that by 3 over 2, our new period will be? Excellent. Three over 2 times pi, or 3 pi over 2. And part C. So yes, you are starting to see that, yeah, you could figure out these things quickly without having to graph it. But we're going to have to graph these all in the end anyway, so this is good practice as we do it. Sine of x over 7. Well, normally we would mark one period at 2 pi, but now we're multiplying things by 7. So one period's going to be 14 pi. If you cut that in half, you would get 7 pi. Cut that in half, you'd get 7 over 2 pi. If you count, 1 7 over 2, 2 7 over 2s, 3 7 over 2s, 3 times 7 is 21, so 21 pi over 2. A sine graph goes up to a maximum of 1 and down to a minimum of negative 1. Where does a sine graph start? Right at the center line. Going up, back to the center line, down to its minimum, back to the center line. And the period is 14 pi. Questions 3, C, and D, practice your period.